Okay, my friends, get ready for this. Webb Space Telescope confirms the accuracy of the universe's expansion rate measured by Hubble, and it deepens the mystery of the Hubble constant tension. It doesn't work. They're wrong. Light slows down. It's not that the expansion of the universe is stretching light. It just slows down. All right, if you look up light, the speed of light, they say it's constant in a vacuum. And that could well be. If there's nothing to push back at it, it could just keep going forever the same speed. But the universe is not a vacuum, isn't even close to a vacuum. It is saturated with particles. And all of the physicists agree to that. Yes, it is. For some reason, they don't allow that to affect their thinking on the speed of light. They say that the universe is pulling the light away, causing it to shift into a longer spectrum. That's not true. It's coming in fast and it's slowing down. As it slows down, the spectrum gets longer and longer and longer until it just eventually basically stops and becomes the cosmic microwave background, which is light just floating around out there that winks on and off all the time as the light that's moving fast hits them, because they're just laying around out there. And eventually the light that hits them becomes the stuff that's laying around, and other new light comes and bangs into them. So this is what it is. The universe is just saturated with particles, and it's called the quantum foam. All right, this isn't me making this claim. This is Fermilab. These are the big guys. Empty space isn't empty. Listen to exactly what it says, because this is really critical, all right, to understand this. The foam on the head of a root beer is a complicated environment. It's always banging out. Now, the bubbles appearing and disappearing in a dizzying display of change. Empty space experiences similar activity with subatomic particles winking in and out of existence. These ephemeral subatomic particles are real and have a measurable impact on our universe and the speed of light. Now, this is Fermilab. Again, this is not me. I didn't make these statements. But we did find the particles that Fermilab talked about, the two smallest particles, the muon and electron neutrino. Again, this is Fermilab, not me. And they say these are the two smallest particles that exist. We did find both of those using our light experiments, and they do exactly what they said. They are, one of them has all the mass, the extended particle is fixed, it just never changes size, and it's heavy. And they have a fuzzy edge, yes they do. Point-like particles are mathematical extractions, zero size. They have no mass that I can determine. But even zero-size particles have extended fluffy field around them due to the effect of the field surrounding them. And that's Don Lincoln from Fermilab. So those two statements about the quantum foam being saturated with particles, and these are the particles, they're light. All right, I'm just going to play this. I did this the other day. Let me turn up the sound a little so you can hear it. And this just talks about Einstein, how he basically destroyed physics and science. Okay, my friends, Albert Einstein broke physics. Well, so why did Einstein destroy physics? This is light in a non-accelerating phase. This is light, which can easily accelerate as you... That's light accelerating right there. That destroys the whole idea of Webb's talking about this, where things are in the universe. If light can speed up and slow down, which it can, it destroys everything they're saying. You can see, this is light spinning in a circular pattern as it moves forward, not in a flappy pattern. This is what the particles look like of light. They have a black and white back to back. They're called... Remember I showed you the ones from Fermilab? It's exactly the same, but these are green ones. The red ones are exactly the same too. Diracs. That's the green, that's the red, the same particle. Blue is the same. Blue. Now look at this. This is blue slowing down, and this is what happens when light comes through the universe. It comes through fast, really tight spin, and That's what happens. So light is slowing down. It's not that the planets or the universe is expanding. Blue shown slowing down, coming in fast, slowing down. So light accelerates, it slows down. It's a particle that spins, it doesn't flap, and around the particle is a big magnetic field which causes a wave. This is the wave, the particle is in the middle. Einstein destroyed physics, ruined the space program, because all we can think about is that light only travels one speed. It totally destroyed everything we know about physics. Okay, my friends, I'm going to leave it there.
Well, hey, if it's true, it's true. My old boss used to say, if it's true, it's true. And if you think you're bragging, if it's true, you ain't bragging. All right, so I'm not bragging that I figured this out, but I figured this out. So you take it for bragging or not bragging.
This dipoles are what all light is made of. There's a black and white particle. Dipole electron flood theory is the new subatomic model that replaces the standard model. The standard model is over, and so is Einstein.
All right, so that concludes that. All right, how anybody could possibly believe that light would come through here and never slow down is not thinking correctly. All of these are magnetic fields. Any magnetic field opposes another magnetic field coming at it, and everything there is in light and these particles moving, they have magnetic fields. So one opposes the other. The light will eventually go boom, 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 boom. And at the same time, all this dizzying, flickering on and off is going on, because one will hit another, and then it'll hit another, and then hit another, and they're slowing down as they come forward. And eventually, they just sit around like this, out in here, called the cosmic microwave background. They're just light particles that are just laying around out there, and then new ones come out fast and bang into them, and then you get this glow in the universe. It's just everything glows, and that's what we've got now. And it's very, very obvious that space is saturated with particles. Light is a particle. I just showed you what light is. And when it comes through the soup of space, there is no vacuum. It comes because there's particles everywhere. There's light particles, there's dust, there's chunks, there's asteroids, there's meteorites, all kinds of things. And they all have fields. You got to plow through those fields. That's the issue. All right, and you can tell that we do have fields and that there is saturation out here, because as we spin through space and the sun, on the surface of the sun is 10,000. Out here it's 1,000,000 degrees at the end of the corona. And that's because this is the scrub zone. As it spins and scrubs through the space, it has to rub its outer atmosphere against this. And that's where you get millions of degrees. Down here, 10,000. Here, 100 or so on the surface. Out here, 2,700 degrees. Same thing we have. We have an attached atmosphere that has to go with us through the space, scrubbing these particles. And it creates the ionosphere. Ions are extra electrons. They're just very energetic electrons, which create a very lot of heat. The same thing out here, exactly same thing. So, as far as I'm concerned, the expansion of the universe, you can close that case. It may be expanding, but that is not the reason for the redshift. So we have to start to really think. And I know right now they realize they're not right, because they say if they look in one direction, it should be the same expansion as over here, but it's not. This one may not be expanding much, and this might be expanding a whole lot. Why? The reason is this one has no particles in front of it, and the stuff is going real fast. This one's going into some soup, whatever. So there's a different density, put it that way. So the light slows down more over here and less over here. So we see it as two different expansions, which is not, they can't account for that either. They can't account for anything, they say. And they just fluff it off and go on about their way and put in for their funding, and we got to figure this out. Well, I think we got to figure it out. It's just got to be looked at and thought about in a little bit different way. All right, thank you. I love you all. Einstein basically destroyed physics and cosmology, all of this. If you have to stay with the speed of light being consistent in the non-vacuum of space, then you're just lost. And to not discuss it and not even think about it is not right, especially because it's costing us billions and billions of dollars every year to look for something that's already been found years and years ago. So I don't know what to say anymore. I really don't. It's a game of who's in control and who wants to decide to say what, and then you have to say what they tell you to say, or they'll fail you. If you go into physics or into cosmology or any of this stuff, and you start to say, "Oh well, the light speed slows down," or "That's when there's no redshift," you're done. Nobody can speak up anymore and keep their position in life. Okay, this is the new theory, is dipole electron flood theory, and these are dipole electrons. That's one, and that's another one. Back to back, they make a photon. These are the particles that they found at Fermilab and CERN, Lawrence Livermore, all of them. See the same particles, but they see them in a bunch of debris, and they don't realize they were attached together like this to make the actual photons. Then we took this, which, remember he said it has a fuzzy edge? Well, here it is right there. There's the fuzzy edge right there. This is right from Fermilab. I didn't make this. This is theirs. And then they have the point-like particles. Now, I can't find any mass at all on that. When you see a hit of a house in a nuclear bomb, the first thing, the house just goes up like this, and then this one comes and knocks the whole house over. So I don't think there's any mass to that at all, that I can tell. But it is attached to the black one. The black one is like the carrier, and it will push the white. There's no question. I can show that as well. Now, in addition to that, we took these light particles, which are basically the smallest particles that exist that they knew of, and broke them apart and separated the muon and electron neutrino. And here it is right here. That's the muon is the black one, and the electron neutrino is the white one. And when they broke, the electron went into a shower. See, electron shower? And the muon just went on its way, the black one, all by itself. It never changed. They're exactly the same size over here as over here or everywhere. But this is fission and that's fusion. There's no other way to look at it. It came in here as a complete particle, and it broke apart here, and it came back together here. That's fission fusion. This is before it hit, and after it hit, it just went into the white and the black. No other way to look at that. All right, I think I showed you the green and the red are identical, but this is what the photon looks like. And it comes through here, and here's the field that surrounds it, the particles down here. That's why they always say particle wave. What is it, a particle or is it a wave? It's both. This here has to make all of these other particles out here, which have the same electrons. And an electron pushes an electron, they glow. That's why this is glowing a lot, and these are just glowing a little, but they got to get out of the way. And that's what it's hitting into this. That's why it causes a wave, and it's a particle. So, everything is solved with dipole electron flood theory. There's nothing that isn't solved. And this goes back to a paper I wrote in 2019, but I've had this theory for forever, since I got out of the Army in 1970. And I confronted my professors with this, and it did not go well. So anyway, there's nothing but dipoles. It's impossible to have a huge proton, which is a huge, enormous positive charge. Well, it's actually supposed to be one gigantic proton, and then one tiny little electron have this exact same charge, only opposite. It just doesn't, they just go snap together. It never did work. It can't work. It's impossible. Light slows down. Every particle there is has a field surrounding it, and every other particle that hits it creates energy. And going through space, as I showed you, no way in anybody's world can a particle come through there without slowing down. And that's why they look over in this direction and then that direction, and they say, why is this one slowing down faster than this one? Well, this one's slowing down faster. It's coming through more soup. And they can't explain any of this stuff, and they keep coming up with bubble theory and all kinds of crazy things. That's the new thing, is bubble theory. I'm not kidding. Yeah, see, this is beyond Einstein, a solution to one of the great mysteries of cosmology. Yes, the mystery is, why didn't anybody believe him that light wouldn't slow down? It's insanity to believe that. All right, listen to this. They come up with the solution to this problem.
It says the universe is expanding. Well, that's their claim. How fast it does so is described by the so-called Hubble-Lamate constant. But there is a dispute about how big this constant actually is. Different measurement methods provide contradictory values. Yeah, because it doesn't work. The so-called Hubble tension poses a puzzle for cosmologists. Researchers from the University of Bonn, St. Andrews, are now proposing a new solution. Yeah, the Hubble bubble. Using alternative theory of gravity. They got to change everything. Alternative theory of gravity. The discrepancy in the measured values can be easily explained. Yeah, no problem. No, we got it all figured out. We're just going to change gravity. You see, this is just amazing. It says, this guy, Krupa, says the universe therefore appears to be expanding faster in our vicinity. It's going faster. That is up to a distance of around 3 billion light years away from us. It's really taken off quick in its entirety, say Krupa. And that shouldn't really be the case. So what they decided was, however, there has recently been an observation could explain this. According to this, Earth is located in a region of space where there is relatively little matter compared to an air bubble in cake. All right, so think about what that statement just says. There's relatively little matter in there, so the light isn't slowing down as fast as it would somewhere else. That's all. That's all it means. All right, think this over. They're saying it's expanding faster in our vicinity. Well, what does that mean, it's expanding faster? It means the light is slowing down more. They're saying it's pulling away, so the light is slowing way down like this. Now, they look over in this direction, and the light isn't slowing down much. It's only slowing down a little bit. So what could be the difference? There's so much stuff over here that the light has to come through. It's really slowing down. By the time it hits us, it's like this. Over here, there's nothing for it to hit into, so it's coming down and it's just barely slowing down. And so you have two different things. This one appears to be everything's going away faster, but it's just that the light is slowing down more because there's more density here. I think they have this just exactly backwards. An air bubble in a cake. But they understand that having these gravitational forces, and these are gravitational forces. These are gravitational forces. Gravity is magnetism. Gravity is magnetism. Dark matter is is gravity. Dark matter is gravity. It collects the white matter surrounding it. And they did an experiment in space, the Russians, and it showed exactly that. The black matter collected in the center and the white matter surrounded it. And there's a lot of dark matter virtually everywhere because the white matter is attracted to the dark matter. The Earth has to be saturated with dark matter. All electricity goes exactly right to ground. Bzzz, lightning, static, all light hits, it all gets absorbed by the ground. The ground has to have a lot of extra dark matter in it, as far as I can determine. Right? All electricity, the white stuff, which normally is attached to the black stuff. Like this. All right, but when you separate the white stuff on you like a static and like electricity, is nothing more than the white stuff. It doesn't have any of the black stuff to it. And zip, it goes right to the ground, which has all the black stuff. The ground has to be saturated with the black material. And that's because that's the only stuff that has mass anyway. Because if the whole Earth was made out of this stuff, the white stuff, you just will fall right through it. It has no mass. It has no mass. The black has all the mass. So the Earth has to be primarily dark matter as far as I'm concerned. They have no idea what's below our feet. You go a couple of miles down, there's no clue what's down there. But something is sucking all light into the Earth. And all electricity and all electrons, right to ground. If you're going into physics or anything like that, you should have the ability to ask your professors, what about this dipole electron flood theory? This is light. This is no question, that's light. That came from a red pulse laser. The green ones came from a green laser. This is what it is. And they're the same identical particle. I'll show you, hold on. All right, let me just run through these pictures and then I'll close it up. Remember I said the Russians did this, and here it is right here. This is the dark matter collected in the center and all the white particles surrounded it. But this is in a zero, this is in a vacuum chamber, and this is in zero gravity, and they flipped out. They couldn't, this goes back 8 years ago. Now, I said the black pushes the white. Here it is right here. The black can push the white. But the white has no mass to it whatsoever. I showed this thing burning down a house. It burns the house completely down. It just vaporizes, and then the black comes and hits it, knocks it over. The black has all the mass. The white has no mass whatsoever. So if you stepped on that white, you just fall right through it. There's nothing there. It's just energy. And here's the green, exactly the same as the red I showed you before. There's the green. And here's the green in its neutrino phase prior to turning into a photon. And the red has the same exact neutrinos. Here's the red. All right, there's the red in their neutrino phases, you see it? And here's the actual photon phase just before it hits the Venturi. These ones here are much more pronounced because they're stacking up against the Venturi. This is where all the energy is piling back up. And then you have extreme reverse magnetic field. You see this? Right here, that's reverse magnetic field. Oh, these are being highlighted because they're coming this way, but they're being blasted back by this explosion. This should lead to free energy. I can't see why not. That white is just nothing more than free electricity. There's no mass to it. And it comes back together as Higgs fields. And this is the new dipole electron flood theory particle. Now, forget that. I'm going away from that. I'm going to stay with this one, which is the core of all the black stuff goes to the core, just like the Russian one, and all the white stuff goes around the outside. And that white stuff, if there's too much of it or there's too little of it, it might bond with something else, and that's how molecules form. And that's the photon, as I showed you. Half a photon is really what was always considered an electron. The black is dark matter. It's dark matter. You listening to me? It's dark matter. And that is the only thing that has any mass. The electron doesn't seem to have any mass at all. You charge a car up and you drive 500 miles and then you charge it back up again. It weighs the same weight after it's discharged or charged up. They don't add any weight. And I showed it. I have a video on it the other day. A guy charged up his car. Well, he had it totally discharged. And then he had put it on a scale, a regular car weight scale. And there was 4 pads, and he had it all up on there. And then he drove, then he charged it up. And it still weighed exactly the same as when he started before it was empty. So you don't add any weight. And that's exactly what I found with that white stuff. It just has no weight. But a lot of energetic value. The black has no energy. It doesn't absorb, it doesn't emit, it doesn't reflect, it doesn't do anything. It's the mass, and the white collects around it. It pushes the white, but that's it. All right, so I'm going to leave it at that for now. Anyway, the story about Einstein and all this business, this is crazy. It really is crazy. The expanding faster in our vicinity. No, it's the light is slowing down more. Or no, the light is slowing down less in our vicinity. It's slowing down more where it looks like it's going faster away because the light just gets slower and slower. They think it's just pulled faster and faster. Totally wrong. All right, just think about it this way. I know that was confusing, and it is going to be confusing. If there's not much stuff in space, and the light is coming through here, the light's going to be coming fast. There's nothing to slow it down. If it's coming through here, and there's a lot of stuff in front of it, big piles of stuff in front of it, it's going to go and slow down. All right, so you hit real redshifted down here, and you'll become much faster from here. And they think that's due to one of them going fast away and one of them going slow away. No, it's due to the fact that one of them has a lot of density and one of them doesn't have much density at all. You know, the idea about the redshift isn't wrong, and I can prove it isn't wrong right here. Because this is a blue shift. And how could it get to be a blue shift? Well, blue means that it's crushed. In other words, here's what happened. The light is coming at the moon here from every different direction. All right? But the moon is moving this way fast. So all of these are just sort of, you know, slow looking light. But here it's crushing against the light, so the light is now coming out blue. So if it was being pulled away, yes, it would shift to the red. I don't disagree with that. I just disagree with the fact that the universe is expanding and light can't slow down. Light obviously can slow down. There's no question whatsoever. Absolutely zero question about this. How they could possibly dismiss this is impossible. And I showed the light is speeding up and slowing down. I showed the blue. I don't think I did. I didn't show the blue, but I can show it. Well, I'll show it to you. All right, you see there's the blue coming in and shifting towards the red. It's coming in real hot blue, and then it's shifting towards the red. Now, I think I showed you the red accelerating. So light accelerates, light slows down. This nonsense of light being the same speed just isn't correct. And the space is not a vacuum, 100% certainty of that. You see this? I just sat in on a Department of Energy speaking about giving $20 billion to people to figure out the how of what we can do to create energy. It's right here. That white is as pure energy as you can get. And we did nothing other than shine it through a Venturi with a laser. I can't see any reason we can't harvest tons of that white by just shooting through lasers, through a Venturi, and harvest the white into basically like a solar collector down into a battery stack or run it whatever device you want. And you could carry this around in a little handbag, just a little lunchbox. And it couldn't hurt you because you're only working with light. And it comes back together instantaneously after it comes through the Venturi. But what we would do, we would have to intervene right here. Right there. So you put your harvester right there. The laser shoots, you know, these are tiny, tiny, tiny devices. I mean tiny. You could have in something like this here. Oops. This is just a little mock-up thing I made, but if you could put all your lasers and the receivers inside of here, and you could put literally thousands inside of here, and every one of them pumping out that very raw white energy. Normally you have to do a lot of work to separate the black from the white. We did nothing whatsoever other than shine it through the Venturi. We let the Venturi do the work. You have to tune it correctly to get that fine crushing event, and then you get this raw energy. And if you harvest that before it hits these are Higgs fields, and let's see this. See how this purple one's coming out here? That one's getting pinched by the side. So this one here, usually they come out all in the same color, but you can see that one's getting pinched to the side. And I have another one shows it elongating. I have hundreds of pictures of this stuff. And anyway, I think I've shown a pretty good, presentation that this thing about the expanding universe is just, it might be expanding, but that has nothing to do with the redshift. And the speed of light slows down. Case closed. And redshift means literally nothing. It means something's slowing down faster than somewhere else because there's more stuff in the way of the light.